Okay, so what is regularization? Okay, the main question is what's the regularization and why we need it. Okay, for that, let's have a look at regression problem. Okay, so this is a regression problem. So we have x and y, so data points are given. Before there are n data points are given, and we want to find a function f such that when we say we want to find a function f, it means we want to find a function f's w parameters such that when we apply that function to x, we get the y back. Okay, so we want to create a relationship in between them. So can you guys see a mouse? You guys see my mouse here right now, or that is not visible? Moment.
No, sir, we can't.
No, guys, is the mouse visible?
No.
No, not yet.
Okay. So what about now? Can you see something?
Yes, we can see.
Yes, sir. Yes, sir.
Okay. So we already have is we have data points. So they are particular. Generally, what we have is we want to find the relationship between the x and y. Okay. So we want to find this relationship between them. Okay. We want to find this link between them. Okay. That's what we want to discover. So, so mostly this function f is defined by its parameters, okay, by w. We want to find its parameters. Okay. So these are w we want to find. Okay, so let us define a loss function. So it's whenever we want to try to do the modeling, one of the things we do is that we try to do the loss functions. And in loss function, we can have different kind of loss. This is generic representation of loss function. It just tries to tell you the output of this guy is how much similar to the ground truth we are given. Okay, so this is also called data fidelity term. Okay, so in mean square error thing, it is called data fidelity. So let us find the model now. Okay, so whenever we do the regression or any kind of a modeling, the two things we need. Number one, we need a loss function, and also we need a model. What are we trying to model? So let us define a generic model. Okay, so this is actually a regression model. Okay, a polynomial regression model where d is defined by the degree of the polynomial. Okay, so for if d is equal to 1, if d is equal to 1, this is sorry, my apologies, this is w1 w1 multiplied by x1, okay, plus w2. Okay, for d is equal to 2, it would be w1 x plus w2 x square plus w3. So you can see that this w3 is which is without any x is actually a biased term. Okay. Okay. So when d, so let's look at this data. Okay. So this is the data, and data represents the true function from which this is sampled. Okay. 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 So okay, I can't see the faces, so I need to assume that you guys are getting it. Okay. So so let us look at this one. When d is equal to 0, our function has no capacity. It cannot represent anything. It will give only one value, which is of the bias. Okay. So let's suppose that d is equal to 1 is a linear regression, so we can see the line. Okay, so if we increase the degree, slowly our function starts to become better, starts to try to model the values it has. Okay, then fit them up. It's so good that eventually we reach a point, we reach a degree that our function can totally fit the points, that there's no loss. Loss is my equal to 0. Okay, so when we started from here, the loss was extremely high, it can fit anything. Slowly our loss decreased, it started to fit that data. Okay, now the problem is this one, is that when the problem is this: if you fit it on the, okay, I missed one of the points. Okay, so the problem is this, that if we have this situation where d is equal to 9, I'm fitting my data very correctly. I'm actually, my loss is equal to 0, so this guy is actually 0. Okay, so this guy is 0. So this should be the function I should pick up. Okay, because data fidelity term is 0 now. It's saying that my function is correctly representing my data. Problem is this, that when I get unseen data, okay, so suppose that there are other samples which I have ignored, and those are like these. Okay, so they are like something like these. Okay, somewhere some like these. Okay, so when I get that data, okay, my loss on this unseen data is very high. Okay, so this unseen data that's sampled and is not available to my learning function during the training, my loss will be very high. Okay, so this fit, which is very good fit of my training data, is not generalizing for unseen data. Okay, that's the problem. Okay, so let's work more on it, what it means actually. So when our degree was equals to 1, okay, our degree was equals to 1, and these green dots are, suppose these green dots are my test values. Can you see those? So these are my test or unseen samples. Okay, so my training error was very high. So you can see that this guy is very far away from this point, it's very far away from this point, it's very far away from this point. So loss function was very high, very high. Okay. Okay. However, the loss function was very high for these guys also. Okay. Now, how can the loss function could be high for many reasons? What we are saying here is this, that when d is equal to 1, regardless of how much training I do, regardless of how much data I provide, my function cannot represent the underlying model. It cannot represent that because it doesn't have a capacity to represent it. Okay, so whatever, so for example, other line could have been like this one, other line could have been like this one. Whatever the lines I choose, they will never represent, they will never be able to capture complexity of the data, the complexity of the baseline function. Okay, so my training error is very high, my testing error is too high. Okay, and I have a high, this is something that's called high bias. The high bias, and it is underfitting. Okay, it's underfitting. Now there's a relationship between the capacity and high bias. Okay, okay. So what means by high bias? It means by high bias is that I'm determined before even starting to look at the data, that what could be the relationship between that, what could be the relationship of the function and the data itself. Okay, I'm biased about it. I have predetermined the type of function I'm looking at. Okay, so I'm not going to say that it's going to be quadratic, I'm not going to say it's cubic, I will not let data say anything. I will decide it myself. This is my bias, that my function is so rigid that it cannot totally represent my data, but I feel this is how the function should be. This is the relationship between x and y should be. Now, what is going on is that if I pick up this data, for example, let me change my pointer so that we can have a different color for that. So let's use the green. So if I pick a line here, okay, if I pick a line, this the way I'm picking a line here, okay, it's saying it, but it's saying there's a linear relationship between x and y, that whenever x increases, y also increases, or y also decreases, but linearly. Okay, okay. So this is what is going on, is that by fixing the type of function, I'm forcing to pick up one of the models which cannot totally represent data itself. Okay, let me repeat this. Let me actually revise this statement. I have preconceived ideas what functions could be, and I'm using those preconceived ideas to force my training method. I'm not letting my data speak to you. Okay. Okay, so that results into high bias. I'm very much biased towards certain functions. Now, this is not a bad thing if we have only few samples. Okay, if you have only 20, 30 samples, and that's only samples you have, and they are, and you're pretty certain what kind of representation would be, then you can pick up a low degree polynomial and present your data in it, and in that way you will say that, okay, I've trained it well. However, when your dimensions are very large, and your data is not as simple as a linear regression, having a low capacity function is not something you want to go for. Okay, so on the other side of the spectrum is overfitting. So overfitting, as we saw, is that it has my apologies, it has captured data, it has fit the same data very well. The loss has gone to 0. Okay, so it has captured the data perfectly, but it doesn't generalize. It doesn't give a low loss function, low value over to the over unseen data. Okay, it is a high capacity. It has a high capacity to represent many different kind of functions. Actually, if the polynomial degree is high, I can say that it can represent almost all of the functions. Okay, it is a high variance. Okay, it's a low bias. It is not based on my preconceived ideas. It is not coming from अच्छा मैंने तो ये सोचा हुआ था इस तरह होना चाहिए. No, it's letting the data speak to itself. But unfortunately, it has a high capacity that it can fit anything it wants to. Okay, one of the reasons could be that by increasing the capacity of my function, I have not increased my capacity of I not increased my, so I increase the capacity of my function by hello.
So can you please tell about capacity? What does it mean by capacity of a
Okay,
function or model?
I will be coming to that. Okay, so by increasing degree, for example, by increasing that, so by increasing my degree D, okay, what I've done, I have actually increased the set of functions that could be represented. Okay, so if my degree was equals to 1, I could only have linear functions. Huh? Okay, but degree is 2, I can only have a quadratic function or a linear function. Okay, because in quadratic function also I can set the W such that, so in quadratic function I also can set the W such that the high degrees are equal to 0. High degrees are not taken in consideration. By increasing my degree, I'm increasing number of possible functions. I'm increasing my hypothesis. Okay, I'm increasing the size set of my hypothesis. Okay, so I'm increasing capacity now. Okay, is it that does that answer your question?
Yes, sir. Okay, thank you so much.
Okay, so by increasing the degree, I'm actually increasing the number of possible functions that could be there. Okay, so it's increasing the capacity. It can say that the data is not quadratic, no problem. I can fit the cubic also because my degree is 10, 9 or something like this. So I can fit the function which is represented by degree equals to 4. So I can represent many different hypotheses now. It's a very high variance. Okay, and I have very low bias. It's not come from preconceived ideas that what we know about the data itself. It's let the data speak. Problem is this: when I increase my set of hypotheses, I need to increase my constraints too, or number of samples too. If my data is enough, and usually whatever the case, data is never enough. If my degree is considerably high, or my capacity is considerably high, usually we don't have enough data samples. Okay, to remove all the possible hypotheses and pick only 1 or 2 of them. Okay, so this means that depending upon the data and the noise in the data, I can fit anything. So even if my data has a noise, my function will fit it. So so I have a high capacity, but I have a low training error, but I have a high testing error. Okay, so even my training error is low, so you can see that all this curve is passing through all the points. अगर यहाँ पे कोई और point भी होता ना, यहाँ पे होता इस तरह करके यहाँ पे कोई point होता, this function would have gone over it by increasing my degree. 9 नहीं तो 10 पे हो जाएगा, 10 नहीं तो 11 पे हो जाएगा. But if I keep if I had noise in the points, it would have modeled it also. So again, in underfitting, I'm not representing the function well, and even in overfitting, I'm not representing the bias function. So मेरा सही true function उसको represent नहीं कर पा रहा. Okay, so in underfitting, function has the capacity to represent a complex functions. Okay, my model doesn't have a capacity to represent the complex functions. Okay, complex function मतलब वो कितना complex mathematical कहते हैं complex relationship को represent नहीं कर सकता. Okay, similarly in our other side overfitting, I have so many hypotheses that anything could be true. Okay, इतनी सारे hypotheses हो गए मेरे पास कि कुछ भी true हो सकता है. ठीक है, I can fit anything in. So कहते हैं I can fit so I can fit see data, I can do anything. So my training error becomes zero. Okay, now the thing is this, we can get a handle of this. In learning, we have a training error is high, testing error is high too. In overfitting, we have a low training error, we have a high testing error. So करें क्या? So one of the strategy is to have some training data set and testing data set, okay, and plot the curves over it. Okay, so you change the number, you change the degree. Yeah, anyone? No. Okay, so you change your degree, you increase your degree slowly, and slowly your testing error starts to decrease and your training error starts to decrease. So this tells you that you're coming out of the underfitting. Your model is becoming more complex because your training error is decreasing and your testing error is also decreasing. Okay. So you keep going down, keep going down, and then you keep increasing your capacity, your degree, and your training error keeps going down and down and down. This tells you that you have recovered from underfitting. Okay. The problem is this: that as I am recovering from the underfitting, I'm overfitting. I start to overfit. Okay, and how that is representative? My testing error is decreasing. Sorry, my training error is decreasing. My testing error is increasing. So what is testing error? Testing error is error on samples which we have not seen before. Okay. Okay. So how do you do that? How is that? You pick up a location where both testing and training error was small, okay, and after which testing error started to increase and training error started to decrease. Testing error started to increase, but the training error kept increasing. This is where you stop. Okay, this is where you stop. So this is how the algorithm is. So first divide your data into training, testing, and validation. Okay, so testing and validation are something you keep during the training. Oh, sorry, my apologies. So training and validation is something you keep during the training steps. Okay, training is something over you you pick up a set of parameters, you pick up your D. Okay, you train on this data set and test on this validation set. So okay, and then you keep changing your D. Okay, until what becomes such that if the training error is also low and your validation error is also low, and if you increase the D, then your validation error starts to increase, but training error keeps decreasing. Okay, or remains same. Okay, this is called early stopping. Okay. Okay, so you keep changing the degree. You keep changing degree. Remember, what's the degree? Degree is set of parameters. Okay. So what are the parameters? Parameters allow my function to be more tunable. Okay. Okay. So you तमाम levels हैं जो कि आपको कई different नजर आएंगे. ठीक है. अब मैं bias और variance नहीं पढ़ा रहा आपको, वो आप खुद देख लीजिएगा. ठीक है. कहते हैं bias variance trade off क्या होता है वो खुद आप देख लीजिएगा. General idea देना चाह रहा हूँ. So by and I'm only giving example of a polynomial of a regression, but this could be true for many other things also. So in a polynomial regression, if I'm increasing my degree, I'm increasing number of parameters too, and by increasing the degree, increasing number of parameters, I'm giving my algorithm more power to tune them, to fix them. Okay. Okay. So when I'm giving more power to my training method, this means that my training method is picking up कि कौन सी चीज है जो मैं करूं तो ज्यादा अच्छा fit हो सकती है data के साथ. Okay, so if my parameters increases, this my model becomes more and more. It has more capacity to fit the baseline function. Okay, and this also means these are parameters which I learn which will I learn during the training also. Okay, so what we do is that we slowly start increasing capacity of our model. हम पहले बड़ा सिंपल सा मॉडल रखते हैं, ठीक है, देन उसको कॉम्प्लेक्स करेंगे, देन उसको इंक्रीज करेंगे, देन उसको इंक्रीज करेंगे, देन इंक्रीज करेंगे. एक टाइम ऐसा आएगा जब ट्रेनिंग एरर जो होगा वो इंक्रीज करता रहेगा, बट टेस्टिंग एरर या वैलिडेशन एरर जो होगा या वो स्टैटिक हो जाएगा या वो इंक्रीज करना शुरू कर देगा. दिस इज द टाइम
Sir,
is called early top. Yes.
I have a question. What if there are fluctuations in between some points in these curves? What does that mean?
Oh, so what we do is that you don't. So see, this is the problem is this one is that whatever functions we are doing are the stochastic ones. हम लोग कहते हैं मिसाल के पे मिनी बैच कर रहे हैं या हम लोग तो हम stochastic gradient कर रहे हैं या मिनी बैच कर रहे हैं या हम उसको डाटा के अंदर augmentations इस तरह की चीजें वेरिएशन करें. तो mostly what you do is that you don't look it on over into just one step. Okay. So you look at our past few trend कि ट्रेंड क्या चल रहा था, पहले कहाँ पे ये चीज चल रही थी, इस तरह हो रहा था क्या मिनी बैच के ऊपर, क्या आधा डाटा को प्रोसेस करने के बाद जब मैं टेस्ट करता हूँ तो क्या तब भी यही बिहेवियर आ रहा था. तो वो एक फ्लक्चुएशन स्मूथ कर देता है. ओके, ठीक है, तो आप पिछला ट्रेंड देखना शुरू कर देते हैं कि क्या मेरा वैलिडेशन एरर पिछले 5 इटरेशन के अंदर कम ही हो रहा था, क्या मेरा टेस्टिंग एरर पीछे कम ही हो रहा था. सही है. And then what you do in generally what you do is that you save the models. जो पिछले models हैं वो सेव करते रहते हैं. Okay, तो उमूमी तौर पे आप 3 या 4 epochs होते हैं उनके हर 3-4 epochs के बाद मॉडल सेव कर लेते हैं और उसके दौरान जो है ना आप उन 4 epochs का कंपैरिजन कर लेते हैं कि उसके ट्रेंड क्या है. उमूमी तौर पे किया जाता है. तो फ्लक्चुएशंस would be there would be definitely fluctuations. को आप स्मूथ करना पड़ेगा. And we know how to smooth out the fluctuations is by taking the mean average, है ना, smooth filter.
Another thing, what if the error is decreasing gradually, but it is bouncing between 2 points?
Okay, so this is a different question. This is a different question. Okay, so what's the accuracy and what's an error? Okay, now actually the word error is not a good term here because I think so you're talking about classification. Okay, in classification we have in classification we have an accuracy and the loss. Okay, so there's a misclassification error, there's a misclassification error, and there's a loss. Okay, so what's the misclassification? So what is the loss? So loss is a कहते हैं क्लासिफिकेशन लॉस कर रहे हैं तो एवरीवन नोस के हम लोग क्या इस्तेमाल करते हैं, सिग्मॉइड. फॉर एग्जांपल अगर हम बाइनरी क्लासिफिकेशन कर रहे हैं या सॉफ्टमैक्स तो हम प्रोबेबिलिटी आउटपुट करते हैं, याद है. ओके, सो वी हैव अ प्रोबेबिलिटी फ्रॉम 0 to 1. ओके गाइस, hello.
Yes sir, yes.
Oh yeah, sorry, I have it. I have to say the guy who's asking a question, he at least should respond. Okay, so let us assume that we have a sample X. Okay, and that guy was labeled as 1. Okay, that guy had a ground truth. Okay, 1. Okay, suppose that by applying function f, okay, I get a probability, okay, which is actually 0.75. Okay, so what is the loss here? Loss is 1 minus 0.75 square. Good.
Yes sir.
Actually square नहीं आएगा. Yeah, depends upon we taking the L2 or not. But yeah, so it's 1 minus 0.75.
Yes sir.
Okay. So actually, my apologies. This is not how there. Actually, it would be 0.25, है ना? Point.
Sorry sir, I can't hear you.
It would be 0.25. It would be 0.5.
Yes sir, 0.25.
Okay. What would be the misclassification error? What would be the misclassification error? Misclassification error depend. Hello?
0.25.
No, misclassification error would be 0.
Oh yes, misclassification error would be 0.
Why?
Loss error will be 0.25.
Because you have classified it correctly. This guy was 0.5 here. So you have classified it correctly because classification comes after you have predicted the probability. So probability 0.753 was greater than 0.5. So you labeled it correctly. Okay. But you have labeled it correctly. Okay. But you have not your loss is high because आपने 1 के पास नहीं पहुंचे. आप threshold से ऊपर हो गए, but आप 1 के पास नहीं पहुंचे. Okay. Okay. So this is a difference there. So in classification, your loss function is decreasing. It is possibility that your accuracy could be your loss might be decreasing, but your accuracy is not increasing any further. Why? Because this guy start moving here. So आपकी misclassification accuracy decrease नहीं हो रही, या accuracy increase नहीं कर रही, but आपका loss कम होता जा रहा है. Okay, ठीक है? And can go other way around also.
Okay, sir.
Okay, does that answer the question?
Yes, sir.
Okay, so अभी तक हम लोग बात पिछली बात जो कर रहे थे वो number of parameters पे कर रहे थे, ठीक है? The same thing could be done. The same thing the same thing could happen for the training, number of training examples also, number of also. आप में से अब जिन लोगों ने नेटवर्क असाइनमेंट की थी, जो असाइनमेंट काम कर रहे हैं, they would be working on number of epochs. Okay, so here also you can use the early stopping criteria to stop your network. Okay, this is not a regularization we are looking for, but this is something you can use के overfit ना करे आपका data. Okay, so you have a validation set, you have a training set, और जब आप train कर रहे हो तो randomly validation set एक रख लें, 25% रख लें, 10 नहीं, actually 70-25 training और testing कर लें, और 10-15% आप validation रख लें, तो validation के बाद check करते जा सकते हैं बार-बार कि मेरी accuracy क्या जा रही है. अच्छा, it can happen now. It can happen that your testing error keeps on decreasing, but your training error doesn't decrease. Okay. Hello.
Sir, kindly explain that point.
It's possible that your training error becomes static, okay, or keeps increasing, and your testing error actually. My apologies. So it's my apologies. I need to finish this up. It is possible that your testing error, training error is decreasing and then becomes static.
कैसे चेक कर सकते हैं
जी?
इसका आईडी भी नहीं चेक किया जा सकता.
जी?
आईडी मैं आपका चेक करना चाहता हूँ, कैसे चेक कर सकता हूँ?
जी, आप कौन इस टाइम बात कर रहे हैं? Hello. Hey guys, please switch off your microphones if you're having conversation with others. अगर आप मुझसे बात कर रहे हैं तो ठीक है, अगर आप किसी और से बात कर रहे हैं तो अपने माइक्रोफोन बंद कर दें. Okay. So this guy, so is a possibility that my training error is decreasing or becoming static, and testing error actually starts to decrease and then keeps on decreasing. It is a possibility. And this happen, and this actually कहते हैं लोग confused हो जाते हैं हो क्या रहा है. It's a simple explanation for that. A simple explanation is this, that your testing data set is much more simpler or much more less complex than your training data set. Okay, if that's the case and you have a validation set, तो अपना validation set को दोबारा से resample कर लें, उसको मजीद complex कर लें. Okay, उसके बजाय तो ये पॉसिबिलिटी हो सकती है, सपोज कर लें कि आप अगर फेस डिटेक्शन कर रहे हैं तो आपने आसान सारे फेसेस हैं वो टेस्टिंग में रख ली है, वैलिडेशन में रख ली है, और मुश्किल वाले जो है ना आपने ट्रेनिंग में रखे हैं. तो इट्स अ पॉसिबिलिटी दैट आप ट्रेनिंग एग्जांपल्स को आप ट्रेन करते हैं तो आपका लॉस तो डिक्रीज नहीं हो रहा, बट टेस्टिंग के ऊपर बहुत या वैलिडेशन पे बहुत जल्दी डिक्रीज कर जाता है. इफ दैट्स द केस, then your testing then actually your testing examples are not true representation of your population. Okay, then resample can be. If there's a question, then I will stop. Otherwise, I will move forward. Okay, there's no question. Okay, now we have talked about the parameters. Now let's go back. Yeah.
सर इसके अंदर हम अर्ली स्टॉपिंग तो नहीं करेंगे ना जब दोनों चीजें ही डिक्रीज हो रही हैं तो?
अगर दोनों डिक्रीज, देखिए इस केस में दोनों डिक्रीज नहीं हो रहे थे, इस केस के अंदर जो आपका टेस्टिंग था वो डिक्रीज हो रहा था, ट्रेनिंग ये था वो डिक्रीज नहीं हो रहा था। दिस इज ट्रेनिंग, ठीक है, दिस इज टेस्टिंग।
सर सर डी हमारे पैरामीटर्स थे, लेकिन न्यूरल नेटवर्क के केस में डी हमारे वेट्स और बायसेस होंगे ना?
नेटवर्क के केस के अंदर
जी यस।
ओ डेफिनेटली। सो अभी आते हैं, हम उस पर भी आते हैं, ठीक है, अब हम उस पर भी आते हैं, उस पर भी आते हैं, एक सेकंड दीजिएगा, ठीक है, ठीक है। लेट मी, मैं पॉलिनोमियल के एग्जांपल से चूज की थी, दैट्स द सिंपलेस्ट वे टू सेल द थिंग, एंड देन वी विल कम बैक टू द नेटवर्क, okay? So what are the parameters, okay? So we want to control the capacity of our model, ठीक है। हमारे दोस्त ने यहाँ पे सही पॉइंट आउट किया है कि नेटवर्क के केस के अंदर, अच्छा अगर हम बात करना चाहे तो नेटवर्क के केस के अंदर पैरामीटर्स क्या होंगे। नेटवर्क के केस के अंदर हम बहुत सारे पैरामीटर्स आ जाते हैं ना, ठीक है। तो असल में जब आपने अगर मैं कैपेसिटी इंक्रीज करनी हो अपने नेटवर्क की, सपोज कर लें बस एक हिडन लेयर का नया नेटवर्क है, तो हाउ कैन इंक्रीज माय कैपेसिटी? by increasing the number of neurons in the hidden layer, है ना? Okay, so this means that I can increase the capacity by increasing the number of neurons in my hidden layer. Okay, this creates a very interesting problem when we say that we want to control the capacity of my network. What are we talking about? Are we talking about controlling the number of neurons in each layer? Okay, now if we try to impose that kind of constraint, it becomes very difficult thing to do. Okay, some people try to do that, but that becomes very difficult thing to train on. Okay, instead of that we try to make our weights to be much more smaller, हम छोटा करने की कोशिश करते हैं, ठीक है। तो हम जो भी लर्न करेंगे we're going to do that, अगर हम नेटवर्क में करना चाहें तो we're going to control the weights itself, okay। then उसके अंदर और strategies आ जाती हैं, we're not going to go in detail, हम उस पर भी जाते नहीं है, पहले हम ये खत्म कर लें, okay। So we want to control the capacity of our model, okay, and but we don't want to retrain our possible degrees, क्योंकि पिछले वाला देखें तो क्या कह रहा था, पिछले वाला कह रहा था कि अपनी डिग्री नंबर इंक्रीज करते जाएं, हर दफा ट्रेन करें, हर दफा टेस्ट करें, हर दफा ट्रेन करें, हर दफा टेस्ट करें। If you realistically this is not possible to do that, okay, okay। So कहते हैं, so what do we say? We say अच्छा ठीक है, we will allow you to use as many degrees you want, okay। So since you want to have a capacity, you want to increase your number of hypotheses, go on, do that, okay। Whichever parameter you want to use, we're going to penalize you, okay। You have to pay for each parameter you use, okay। So whatever parameter you use, we're going to make sure that you have to pay for that, okay। If you want to have a degree of 100, go and do that, okay। But whatever the value is set to that, you will have to pay something to us. Now how we do the payment? Payment comes in terms of a loss function, okay। So payment comes in terms of a loss function. So this is the loss function you have generally seen, ठीक है। delta हमने पहले भी की थी, याद है आपको, okay। This is something extra we apply. This is a regularization term, okay। This is a regularization term, okay, and this regularization term is saying just this thing, and it can have different formulations, but it says just one thing. Number one, if you increase the capacity, you will have to have you have to pay me, okay, okay। So your loss will be higher, okay, and remember we want to minimize this thing, हम इसको minimize करना चाहते हैं, याद है? We want to minimize this guy, okay। So if I want to increase my capacity, I will have to minimize much rigorously, और मैं उस minimization पे नहीं पहुंच सकूंगा, okay, ठीक है। What it allows me to do that is that it force this loss function not to zero। याद है क्या हो रहा था ओवरफिटिंग के अंदर? ओवरफिटिंग के अंदर मेरा लॉस एग्जैक्टली जीरो था, okay। Now by adding this term I am forcing ये बंदा जीरो नहीं हो सकता, okay। इस बंदे का जीरो हमने डिस्ट्रैक्ट कर दिया, मूव कर दिया, ठीक है। Now it can go to different kind of a hypothesis depending upon this one। अच्छा, एक और तरीका यूं है सोचने का, सपोज कहते हैं कि आपके पास आपने डिग्रीज इंक्रीज करने से 1000 हाइपोथेसिस बना ली, ठीक है। मैं इस RW को सेट कर, हो सकता है उससे कुछ हाइपोथेसिस हो जाएंगे कॉस्ट ज्यादा हो, कुछ हाइपोथेसिस हो जाएंगे जिनको इस्तेमाल करने की कॉस्ट कम हो, तो फिर हम वो हाइपोथेसिस, अगर सपोज कर लें 10 ऐसे हाइपोथेसिस हैं जो सारे के सारे जीरो हो जाते हैं, सपोज करें, ये बहुत छोटी थोड़ी वैल्यू देते हैं, ठीक है, मगर उनका रेगुलराइजेशन टर्म बहुत ज्यादा है, ठीक है, हम उनको छोड़ देंगे। हम एक ऐसा फंक्शन पकड़ेंगे जो कि जिसका जिसका लॉस फंक्शन एग्जैक्टली जीरो ना होता हो, ठीक है, मगर उसका आर डब्ल्यू थोड़ा हो, ठीक है, सही है। तो व्हाट इट अलाउज मी टू डू दैट, इट अलाउज मी कि मेरे पास अगर हाइपोथेसिस जो इनफिनाइट हाइपोथेसिस हैं या बहुत सारे हाइपोथेसिस हैं, यहाँ पे सपोज कर लेंगे मेरे पास यहाँ पे 1000 हैं, ठीक है, I don't have a pen right now with me and that is causing a problem, but let's see. So suppose can I have a 1000 hypothesis, okay, तो उसमें suppose कर लें कि H4 जो था उसकी कैपेसिटी थी, वो suppose कर लें उसकी कैपेसिटी थी 10 थी, suppose करें डिग्री 10 का था, और उसका लॉस जो था 0 आता था, ओके, ठीक है, पर 10 की वजह से उसके ऊपर रेगुलराइजेशन टर्म जो लगेगी वो हाई पेनल्टी लगाएगी। उसके मुकाबले में एक कोई H6 था जिसकी कैपेसिटी जो थी या डिग्री जो थी वो 4 थी फॉर एग्जांपल, ठीक है, सही है, और उसका लॉस फंक्शन जो था वो 1 आता था, फॉर एग्जांपल 1.1 आता था, सपोज कर लें, ठीक है, मगर उसकी रेगुलेशन जो थी वो बहुत थोड़ी थी, ओके, तो मैं गोइंग टू पिक दिस गाय अप इंस्टेड ऑफ दिस गाय, ओके, तो दिस इज व्हाट द ऑकम रेजर आल्सो सेज कि जब आपके पास काफी सारे कंपीटिंग हाइपोथेसिस हो to pick up the simplest one. So our regularization term is allowing us to pick the simple one. Okay, okay. Okay. So this general representation. This is the fidelity term. This is my regularization term. This one, this guy. Okay. This guy allows me to control how much value I want to give to regularization. Okay. Obviously, how this is important. This RW typically has these kind of shapes. They're definitely more versions of that, but these are typical shapes. It has L2 regularization, L1 regularization, and elastic net. Okay, elastic net is a combination of L1 and L2 regularization. Then we have a more complex presentation. This is dropout. This is called stochastic regularization. Note down कर लें हम लोग batch normalization